by next year, the greatest threat to the artificial intelligence boom isn't actually going to be government regulation.
Right.
It's not going to be software bugs, and it's not even a lack of training data. It's actually going to be the global power grid physically running out of electricity.
Yeah, we are hitting a very hard physical wall here. I mean, the infrastructure that powers our daily lives, it simply was not engineered to support the sudden localized energy draw of modern supercomputing.
No, not at all.
It's just a fundamental friction point between our digital ambitions and, well, physical reality.
Welcome to the deep dive. We are looking at a pretty incredible stack of sources today because, May 2026 has officially become this watershed moment in the tech landscape.
Oh, absolutely.
Yeah, we are pulling from FCC filings for orbital data centers, a press release from Meta, legal reporting out of an Oakland courtroom, an economic blog post from Andreessen Horowitz, and just a massive flurry of updates from Global Tech Daily.
It is a massive influx of data to sort through, to be honest, but it really all points to the exact same underlying shift.
Exactly. And our mission today is to connect those dots for you. We want to cut through the information overload and give you a clear picture of how AI is quite literally escaping the Earth's power grid.
Literally escaping it, yeah.
Right. How it's rewriting the economy and sparking some of the fiercest legal and geopolitical battles we have ever seen. Okay, let's unpack this. And I think we need to start with the sheer brute force physical reality of artificial intelligence right now.
That's the best place to start.
Because I was reading through the reports on Elon Musk's new supercomputing facility in Memphis, and the scale of it genuinely broke my brain.
You're talking about Colossus.
Yes, Colossus.
It is a staggering piece of infrastructure. I mean, to understand the momentum here, you have to look at how Musk's xAI has dissolved as a standalone entity.
Right, they merged.
Exactly. They fully merged into SpaceX. So that creates this unified $1.25 trillion behemoth called SpaceXAI.
$1 trillion. Wow.
Yeah. And the capital they are deploying into Memphis right now is just unprecedented. They built Colossus, which is currently the world's largest supercomputer, in a record-breaking 122 days.
Which is just absurd. Like, an industrial facility of that magnitude, with all the specialized cooling and power substations you need, that normally has a 24-month build cycle.
At minimum.
And they did it in 4 months.
Yeah.
And they're currently running 200,000 GPUs with a stated roadmap to scale up to 1 million.
And, the sheer gravitational pull of that much compute is already reshaping the industry. I mean, Anthropic, which is technically a direct competitor to Musk's AI ambitions, they just signed a massive compute deal to use Colossus.
Wait, really? To train Claude?
Yeah, to train its Claude model.
Wow. And Claude is taking a massive leap forward, too.
Yeah.
They just rolled out this new capability called Dreaming, which it essentially enhances its agentic autonomy.
Right.
For those tracking the jargon, agentic autonomy basically means the AI is no longer just sitting idle, waiting for you to type a prompt.
It's proactive.
Exactly. It is running background simulations, testing its own code, planning out multi-step tasks, and making decisions while you sleep. But, and this is the catch, having millions of autonomous agents thinking around the clock requires a ton of power.
It's huge amounts of power.
Which brings us right back to the grid.
Yeah, so PJM Interconnection, which is the largest grid operator in the U.S., they're currently projecting a massive 6 gigawatt shortfall by 2027.
6 gigawatts?
Yeah, to put that in perspective for you, if you were wondering why your power bill went up recently or why local utility commissions are actively panicking, this is why.
Right.
We are effectively dropping the energy footprint of major cities onto local grids in a matter of months. Industry analysts are now predicting that 40% of all AI data centers will be physically restricted by grid constraints next year.
Okay, so we have a physical friction problem. The AI needs more power, and the Earth is literally out of wall outlets. So what's SpaceX's solution?
Well, they filed a massive proposal with the FCC.
Right, to launch 1 million solar-powered satellites into low Earth orbit. So roughly between, 500 and 2,000 kilometers up?
Yeah, somewhere in that range.
To act as a constellation of orbital data centers. So essentially, because we're running out of wall outlets and ice packs down here, we're taking the servers outside into the ultimate freezer space.
You're taking the servers completely off the terrestrial grid.
Okay, wait. I understand the solar power aspect. You get constant sunlight up there above the clouds.
Sure.
But how does the cooling work? Because down here on Earth, we pump millions of gallons of water through these server racks to keep them from melting. How do you cool down a supercomputer in the vacuum of space where there is no air and no water to absorb the heat.
What's fascinating here is the underlying physics. You are entirely correct that you cannot use convection. Fans are completely useless in a vacuum.
Right, there's no air to blow around.
Exactly. So instead, you have to rely on passive radiative cooling. You essentially engineer the satellite's exterior to capture the immense thermal energy generated by those GPUs, convert that heat into infrared light, and beam it directly out into the absolute zero of deep space.
Just beaming it away.
Yeah, you bypass the need for water chillers and cooling towers entirely. And because you have unfiltered, continuous solar power plus this passive cooling, SpaceX's projected goal is to reach processing power that costs just 0.1 cents per kilowatt hour.
Wow. Compared to like the 5 cents or more you might pay on Earth.
Exactly.
But okay, let's talk about the timeline here.
Yeah.
Because Musk is claiming they can achieve cost parity with ground-based servers in 2 to 3 years. And I really have to push back on that.
Yeah, that's a tough pill to swallow.
Right. Cost parity in 2 years sounds physically impossible. You are talking about launching 1 million servers into orbit. I mean, even with the massive payload capacity of the Starship rocket, the launch cadence alone to get 1 million satellites up there would take a decade.
Oh, easily.
And that's before we even talk about the physical environment up there.
Well, your skepticism is completely aligned with the broader analytical consensus. While the theoretical economics of orbital compute are brilliant, the engineering realities are brutal.
Very brittle.
Financial analysts project this infrastructure won't reach cost parity until well into the 2030s. Space is just an incredibly hostile environment for delicate microprocessors.
Yeah, you've got radiation, right?
Lots of it. High levels of solar radiation, which degrades hardware and causes literal bit flips in the memory. Plus, you need massive, heavy radiators to handle that thermal emission we just talked about, which adds incredible launch weight.
And space debris.
Oh, the space debris. Adding 1 million new satellites to low Earth orbit creates an absolute logistical nightmare for collision avoidance.
So we've tried to solve the physical power problem by moving to space. But physics creates a completely different bottleneck inside the server itself down here on Earth. Because it doesn't really matter if your orbital data center has infinite solar power if the processor's just starving for data.
Right, that's the hardware friction.
Yeah.
You can build the most powerful AI model in the world, but its speed is entirely dictated by how fast you can feed it information.
And that brings us to RAM, random access memory. According to the stack of reports we have, manufacturers like Samsung, SK Hynix, and Micron have aggressively kicked off the early development of DDR6 RAM.
Right.
For context, the current high-end standard in our machines right now is DDR5, which peaks at about 8.4 gigabits per second. DDR6 is targeting a massive 17.6 gigabits per second to handle the ferocious data demands of these new AI systems.
Yeah, and they are aiming for commercialization around 2028 or 2029.
So to visualize why this matters for you listening, think of it like this. Is it like having a genius chef in the kitchen? That's the AI, but a really tiny serving window. So no matter how fast the chef cooks, the food just can't get out to the dining room fast enough.
That is a perfect analogy. Or you can think of it like a highway system. DDR5 is a highly efficient 4-lane superhighway feeding the processor. But the new AI models aren't just fast cars. They are a sprawling metropolis of 1 billion citizens demanding supplies all at once.
Wow.
The processor is capable of doing billions of calculations a second, but it's sitting idle, just waiting in traffic for the data to arrive. DDR6 isn't just adding a carpool lane, it's stacking an entire second deck onto the highway to double the throughput.
Double the throughput.
And the race to build that second deck is exactly why Samsung, Micron, and SK Hynix are locked in such a fierce development battle years before the product will even hit the shelves.
Because they want to be the standard.
Exactly. They are fighting to set the universal standard. The organization that governs memory hardware JEDEC will eventually evaluate all the prototypes and adopt one specific design as the global blueprint.
And that blueprint dictates everything, right?
Everything, from the physical pin layout to the voltage requirements. Whoever's proprietary design becomes that standard gets a massive multi-billion-dollar head start.
Right, because they secure the market share.
They stabilize their manufacturing yields first, and their competitors are forced to completely retool their factories to comply.
But, all of this advanced engineering comes with a heavy consumer price tag. Apple's CEO, Tim Cook, has been publicly warning about what he calls RAMmageddon.
RAMmageddon, yeah.
Yeah, he's predicting that this surging industry-wide demand for hyper-fast AI memory is going to drastically increase the manufacturing costs of future devices. If you want an AI that can Greem on your phone, you are going to pay a premium for the physical memory required to run it.
The underlying theme here is control. Trillions of dollars are being poured into the physical infrastructure, the power, the space launches, the memory architecture.
Yeah.
And with that much capital and unprecedented technological power at stake, the people and nations building it are fighting aggressively over who holds the keys.
Which moves us from hardware friction to human friction. Let's look at the federal courthouse in Oakland. We have the ongoing, highly publicized trial of Elon Musk versus OpenAI CEO Sam Altman. Musk's core claim is that OpenAI blatantly broke its founding agreement. The organization was originally structured as a nonprofit designed to safely develop AI for the betterment of humanity. But Musk claims they unlawfully pivoted into a highly lucrative, closed-source, for-profit model.
Yeah, and during his testimony, Musk stated on the record that OpenAI stole a charity.
Stole a charity.
His family office also provided financial records, testifying that Musk personally donated approximately $38 million to OpenAI between 2016 and 2020 to fund its early operations.
Okay, and just to be clear and impartial here, OpenAI's legal defense fundamentally rejects that narrative.
Completely.
Their attorneys are attempting to demonstrate that Musk was entirely aware of the structural transition plans, and they're arguing that this lawsuit is purely retaliatory, motivated by OpenAI's massive commercial success after Musk chose to walk away from the company.
The proceedings have been incredibly tense.
Tense is an understatement. I mean, the judge actually had to step in and cut off Musk's testimony.
Oh, right.
Yeah. Musk started pivoting away from the corporate structure and began testifying about the existential risks of the technology, specifically detailing a Terminator situation that could lead to human extinction.
Right.
And the judge shut it down, stating the court was there to resolve a contract dispute, not debate human extinction.
Which is fair.
But I have to point out the glaring contradiction here. Musk is suing OpenAI over their transition to a for-profit model, while at the exact same time, he just folded his own artificial intelligence company, xAI, into SpaceX to create a $1.25 trillion for-profit entity.
It's quite the paradox. But if we connect this to the bigger picture, what is happening in that Oakland courtroom is not just a messy contract dispute between billionaires.
Yeah.
It is a proxy war over who gets to dictate the trajectory, the safety protocols, and the commercialization of human-level artificial intelligence. And that exact same proxy war is currently playing out on the global stage between superpowers.
Yeah, the Global Tech Daily Report points out that the U.S. and China are actively preparing for high-level AI guardrail discussions at the upcoming Trump-Xi summit. The diplomatic language they are using is focused on preventing an arms race of the digital era.
That phrase alone reveals the diplomatic gravity of the situation. Governments are treating autonomous AI with the same strategic caution as nuclear proliferation.
Wow.
Both Washington and Beijing recognize that advanced AI, specifically the agentic models that can code, plan, and execute tasks, autonomously carries systemic risks that neither nation is fully prepared to manage on its own.
Right.
So they are attempting to establish bilateral norms and emergency communication channels before the technology completely outpaces their regulatory frameworks. The fact that this is a priority agenda item for a summit between rival superpowers illustrates just how high the geopolitical anxiety has become.
So we've gone from server farms orbiting the Earth to DDR6 memory bottlenecks to billionaire lawsuits and superpower treaties. Let's bring this all the way back down to Earth.
Let's do it.
How is this rapid AI evolution actually touching the daily life of the person listening to this right now? Because, it's very easy to hear about trillion-dollar valuations and feel like this is just science fiction playing out above our heads.
It feels distant.
Yeah, but it is fundamentally restructuring our jobs, and it's changing how our kids interact with the internet.
The economic impact is where the vast majority of public anxiety currently sits, and it requires a really nuanced look at how labor markets actually function.
And there's a fascinating, highly debated post from the venture capital firm Andreessen Horowitz, or A16 sees. They are arguing that the concept of an AI job apocalypse is a complete fantasy.
Yes.
They claim that the panic over mass, permanent unemployment relies on a well-known economic concept called the lump of labor fallacy.
The lump of labor fallacy is the mistaken assumption that there is a fixed, finite amount of work to be done in the global economy.
Okay.
The flawed logic dictates that if a machine takes over a specific task, there is permanently less work available for humans, leading inevitably to unemployment.
But economic history proves that human wants and needs are anything but fixed, right? A16 uses a brilliant historical example. Travel agents. When the internet arrived, Followed by algorithms and self-booking sites like Expedia, the technology absolutely devastated the sheer number of human travel agents. A massive portion of that specific job is automated away.
Right.
However, the travel agents who remained, the ones who utilized the new tech to organize highly complex, bespoke corporate or luxury travel, they actually saw their wages outpace the rest of the private sector. Furthermore, making travel booking cheaper and easier caused the broader travel and hospitality economy to explode in size, creating millions of new jobs in adjacent sectors.
And we are seeing a similar dynamic currently playing out in the tech sector itself. Despite the proliferation of AI coding assistants that can write thousands of lines of code in seconds, the overall market demand and compensation for skilled software engineers and product managers are actually rising.
Really?
Yeah. In this view, AI is acting as a powerful augmenter of human output, not just a wholesale substitute.
But I have to ask, if AI isn't just swinging a physical hammer but is eventually taking over the actual thinking tasks, doesn't that fundamentally change human value?
That's the big question.
Like if a machine can write the code, draft the legal brief, and analyze the financial data better and faster, are we just moving the goalposts for what human labor is? So what does this all mean?
It's the most profound question we face. What economic history suggests, and the core of the A16Z's argument, is that humanity consistently expands its ambitions whenever a critical resource becomes cheap and abundant.
Okay.
When physical energy became cheap during the Industrial Revolution, we didn't just stop working and go home. We invented entirely new industries, from global shipping to aviation to plastics.
Right.
If the cost of cognition collapses, if deep analytical thinking becomes cheap, abundant, and instantly accessible, we will push into frontiers we cannot even conceptualize today.
Wow.
We will transition from performing repetitive cognitive tasks to orchestrating complex, highly ambitious creative projects. The goalposts don't just move, the entire stadium expands.
And while the economy is restructuring around abundant cognition, the social fabric is also adapting, particularly for younger generations. Meta just announced a major rollout of new AI-powered age assurance measures to strictly enforce their teen accounts, expanding the program across the EU, Brazil, and the US.
This is a major departure from the old system of simply asking a user to type in their birth year, which, let's be honest, kids have easily bypassed for over a decade.
Exactly. The technology Meta is deploying is highly sophisticated. They're using AI to scan entire profiles for contextual clues. So if an account claims the user is 25 years old, but the AI language model detects posts discussing middle school grades or photos of a sweet 16 birthday celebration, it flags the account for age verification. But what really caught my attention is the visual analysis.
The bone structure scanning.
Yes. They are explicitly stating that it is not facial recognition, but the AI is actively analyzing photos and videos to look at bone structure and height to estimate a user's age. How do you scan someone's bone structure without it being facial recognition?
It is a crucial distinction. Facial recognition works by mapping distinct, unique nodes on your face to definitively identify who you are, matching a name to a face.
Right.
This new age assurance AI doesn't care about your identity. It is measuring biological proportions. It looks at the ratio of eye width to jawline, or the proportion of the shoulders to the head.
Oh, I see.
Yeah, these specific anatomical ratios change in highly predictable ways as a human goes through puberty. By analyzing those broad biological themes, the AI can estimate with high accuracy whether the person in the photo is 12 or 22 without ever needing to know their name.
It's a fascinating deployment of the technology to solve a uniquely modern problem,
Right.
creating a safer default environment for minors online by catching the ones lying to bypass safety features.
Definitely.
But it also highlights a profound shift.
Yeah.
Every photo, every post, every digital footprint is now being structurally analyzed by artificial intelligence.
It embeds algorithmic analysis into the very foundation of our everyday social interactions.
It really is a completely new map. Okay, we have covered a tremendous amount of ground today.
We really have.
We started with the physical limits of the power grid, looking at the staggering scale of the Colossus supercomputer and SpaceXAI's incredibly ambitious, albeit timeline-challenged, plan to launch 1 million orbital data centers.
Yeah.
We explored the hardware friction down here on Earth, with DDR6 RAM stacking a second deck on the data highway to prevent Tim Cook's RAMmageddon. We waded into the intense human friction for control, unpacking the complex legal arguments in the Musk versus Altman trial and the high-stakes geopolitical guardrails being discussed at the Trump-Xi summit.
That's right.
And finally, we brought it back to daily life, looking at the lump of labor fallacy regarding our jobs and how Meta is deploying biological proportion scanning to protect teens online.
It is a remarkable convergence of physics, hardware, economics, and law. But as we look at this rapid expansion, specifically that audacious move towards space, I want to leave you with a final thought to mull over. If SpaceX successfully manages to launch the world's most powerful AI data centers into orbit, and Anthropic's Claude is allowed to dream and execute tasks autonomously while floating 2,000 kilometers above the Earth, whose laws actually apply.
Oh, wow.
Right. If orbital data centers become the cognitive backbone of human knowledge, operating in the vacuum of space far above all national borders and jurisdictions, do we need to fundamentally rethink the entire concept of digital sovereignty?
That is wild. It makes you look at that map of human infrastructure completely differently. The lines aren't just leaving the edge of the paper, they're leaving the jurisdiction of the paper entirely. Thank you so much for joining us on this deep dive. Keep asking questions, keep looking up, and we will catch you next time.